Hello wonderful person, this is Anton, and today we're going to be discussing the discovery, a very recent discovery, of an extremely interesting pulsar. Very likely the youngest pulsar ever found, but also the most powerful pulsar visible from millions and millions of light years away from us. Although in this case we're not really talking about the pulsar itself, not about the neutron star, we're talking about the unusual phenomenon that surrounds the pulsar that you can kind of see right here, known as the pulsar wind. The phenomenon that ends up producing extremely powerful radio waves and a lot of other emissions that are visible from very far away distances. With the most iconic one being this one right here, from our own galaxy, the Milky Way. This is the Crab pulsar. And I actually wanted to start here before I explain to you what the scientists recently discovered. Because Crab pulsar by itself is one of the most mysterious, yet one of the most fascinating objects in the entire galaxy. With the pulsar itself being so tiny that it's actually invisible, but being so powerful that it actually ends up producing these very beautiful waves you see, creating a kind of a standing shock wave known as the wind termination shock. Here's what it sort of looks like accelerated and from a slightly different angle. And so in this case, when the wind coming from the center of the pulsar decelerates to subrelativistic speeds, it ends up releasing tremendous amounts of radio energy that technically is visible from super far away distances. And today we usually refer to these objects as Pulsar Wind Nebula, sometimes also known as the Plerion, a Greek word meaning fool. In essence, it's a type of a nebula occasionally found inside the shell of a supernova remnant that also hosts a neutron star right in the middle. With all of this being powered by the central pulsar and its extremely fast rotation. And usually these are found in optical light, they're also found in sub-millimeter and infrared light, but they also release a lot of radio waves as well. Sometimes they produce higher frequencies such as gamma rays. But they also evolve really quickly and they do change within just a few years. But what's interesting about the Crab pulsar right here is that we know that it existed for at least 1,000 years, or just a little bit less than that. As a matter of fact, back in the days, the scientists figured out when this happened. They were actually able to connect this to ancient observations and ancient entries from China from the year 1054, when the Chinese astronomers reported the so-called visitor star. And today it's believed that it might have resembled something like this. It was probably super bright and extremely hard to miss. As a matter of fact, it was reported by a lot of different Asian astronomers, and even today is still visible if you have a smaller telescope and a dark enough environment to observe all of this. But what's really strange about the supernova is that it was never reported in the West. None of the Western records seem to show it. And at least one study that you can find in the description below explores the idea behind this and potentially finds one mentioning of the star after all. And in short, the study explains all of this pretty well. Early Christian scholars very likely did not want to raise attention to something that's changing in the night skies because it would basically violate some of the things they believed in. And it would also create a lot of problems for the early church and the early Christianity. And so nobody in the West dared to write about it or to express it in any way. But the scientists behind the study discovered that there were certain coins that were minted during the reign of the Constantine IX in the Byzantine Empire that seemed to contain an unusual star potentially representing this particular supernova. And was actually only the coins minted between 1054 and 1055. A lot of other coins did not have this star. There were actually two stars in this particular coin, one being Venus and the other very likely being the supernova. And interestingly, the size of the star does differ between 36 different coins that were examined, with the explanation being that the supernova dimmed with time, which changed the appearance of the star on these coins. With the study going into a lot of detail explaining why they believe so, and why they believe that this is indeed the representation of the supernova that happened in 1054, that we now know formed the Crab Nebula. The nebula that even after 1,000 years still produces a lot of radiation and is still actively used for a lot of different Plerion or pulsar wind studies. But generally it's believed that it's really just after the supernova that this particular nebula is usually the strongest. And so as the pulsar wind ages, the supernova remnant dissipates and eventually can even disappear. But over time it can also transform into something a little bit different, sometimes referred to as the bull shock nebula, surrounding various millisecond or slowly rotating pulsars. The bull shock nebula generally produce very different features and are also not as easily visible from far away distances. But in these objects, Pretty much everything happens because of the rotation of the pulsar and because it tends to accelerate things so much in the center. And all of this is very likely due to very powerful magnetic fields that tend to accelerate various plasma particles to relativistic speeds close to the speed of light. And so in some sense, these very powerful pulsars act like very powerful magnets, so kind of like magnetars. Although the actual features on the inside and exactly how all of this evolves is still poorly understood. And very recently, the scientists that were actually studying all of these objects by using the survey known as Weiss have discovered one of the youngest such stars inside one of the brightest and the most powerful pulsar wind nebula ever seen. The Pulsar wind nebula is so powerful that it seems to be visible from roughly around 395 million light years away from planet Earth. And up until the year 2000, this particular survey did not actually show anything coming from this region. The scientists believe it's because the supernova has just occurred, with the star basically reaching its limit and exploding, expanding all of the material away from it. But the neutron star itself, along with a lot of the materials surrounding the neutron star, was still behind a relatively dense shell of debris that was expanding from the supernova explosion. In other words, following the explosion, we still were in a stage where a lot of this was still invisible. But starting in 2018 up until now, new images revealed some kind of a very powerful object that was clearly visible and very bright in the radio frequency of 1.5 GHz. And because this is approximately 20 years apart, the scientists believe that this pulsar could be as young as 14 years old, making this the youngest pulsar, the youngest neutron star, and also very likely the youngest pulsar wind nebula we've ever discovered. And it's very likely a pulsar wind nebula because the neutron star or a pulsar by itself should not really be that bright from 390 million light years away from us. It does require a different mechanism such as the nebula around it in order to create so much luminosity that it's visible from many different places in the universe. Here's by the way where all of this is located. It's a dwarf galaxy briefly known as SDSS J113706, and it's a dwarf galaxy known for a lot of star formation, which means that there are probably a lot of supernova and a lot of neutron stars and black holes being formed pretty regularly, pretty much every single year. And because this neutron star very likely possesses very powerful magnetosphere, overall it seems to appear about 10,000 times more energetic than the Crab Nebula, or 10,000 times brighter than what we have right here in the Milky Way. Which brings up an interesting question. Was the Crab Nebula as powerful when it was just created around 1,000 years ago? And if not, why not? Was it because the neutron star in the middle was different in some way or another? For example, maybe what was produced in this case was not just a neutron star, but an actual magnetar, the most powerful magnet in the universe. Which also means that maybe this is how we could one day answer the question of mysterious fast radio bursts. But that's another question we're going to be answering in some of the future videos. And if this is a magnetar, why was it produced in this case, but not in 1054 inside the Crab Nebula? Or maybe this was a magnetar in the beginning, but then it transformed over time, losing all of its magnetic energy and eventually becoming the pulsar that it is today. So in that sense, we don't actually have a direct answer just yet. But if the scientists start detecting unusual fast radio bursts or some other radio emissions coming from this new neutron star as well, it might actually help us answer so many different mysteries all at once. Mostly because, well, officially this is now the youngest neutron star in existence, and definitely one of the most powerful and one of the most intriguing neutron stars surrounded by a pulsar wind nebula that we've ever been able to find anywhere in the universe. And so investigating this more, or looking for more emissions coming from here, could be the next important step in trying to understand what happens during these extremely powerful supernova that end up producing these very powerful nebula. But I guess for now that's pretty much all I wanted to mention. Once the scientists discover something else, I'll follow this up with another video. Until then, thank you for watching, subscribe, maybe share this with someone who loves learning about space and sciences, and come back tomorrow to learn something else. Support this channel on Patreon by joining channel membership, or by buying the wonderful person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye.